So let's continue our exploration. So the next concept that I want to define is that of arc length. So arc length is just the distance that you have traveled along the curve. Okay? So if you're in a car, it has this mileage counter that tells you how far you've gone, how much fuel you've used if it's a fancy car. And what it does is it integrates the speed over time to give you the arc length along the trajectory of the car. So the usual notation that we'll have is S for arc length. I am not quite sure how you get an S out of this, but it's the usual notation. Okay, so S is the distance traveled along the trajectory. And for that to make sense, of course, we need to fix a reference point. Maybe on the cycloid, we'd say it's the distance starting from the origin. Or in general, maybe you'll say you start at time equals, t equals 0. But it's a convention. You could decide, if you knew in advance, you could have actually your car's mileage counter to count backwards, from the point where the car will die and stop working. I mean, that would be slightly freaky, but you could have certainly a negative arc length that gets closer and closer to 0 and gets to 0 at the end of the trajectory, or anything you want. I mean, arc length could be positive or negative. Typically, it's negative when you're before the reference point and positive afterwards. So now, how does it relate to the things we've seen there? Well, so in particular, how do you relate arc length and time? Well, so there's a simple relation, which is that the rate of change of arc length versus time, well, that's going to be the speed at which you're moving. Okay? Because the speed, as a scalar quantity, tells you how much distance you're covering per unit time. Okay? And in fact, to be completely honest, I should put an absolute value here, because there's examples of curves, maybe where your motion is going back and forth along the same curve, and then you don't want to keep counting arc length all the time. Actually, maybe you want to say that the arc length increases, then decreases along the curve. Okay? I mean, you get to choose how you count it. But in this case, if you are moving back and forth, it would make more sense to have the arc length first increase, then decrease, increase again, and so on. So if you want to know really what the arc length is, then basically the only way to do it is to integrate speed versus time. So if you wanted to know how long an arch of cycloid is, you have this nice looking curve, how long is it? Well, you'd have to basically integrate this quantity from t equals 0 to 2 pi. And to say the truth, I don't really know how to integrate that. So we don't actually have a formula for the length at this point. However, we'll see one later using a cool trick and multivariable calculus. So for now, we'll just leave a formula like that, and we don't know how long it is. Well, you can put that into your calculator and get a numerical value, but that's the best I can offer.